Okay, my name is Pen Wu and my group member is in year 2. In our presentation, we will introduce I/O management and discuss scheduling, file management. In my part, I will introduce I/O management and disk scheduling and the secondary storage. So here you can see three types of I/O device. The first one is human readable. It's suitable for communicating with the computer user, like print and terminal. And the machine readable is suited for communicating with electronic equipment like disk device and USB key. And communication means suitable for communicating with a remote device like digital lines, drivers, and modems. They are different because they have different data rate, application, complexity of control, and unit transfer and data representation. So what about the block-oriented and the character-oriented device? So here you can see a chart. Block-oriented, it means information is usually stored in fixed size block, and one block is transferred at a time. Data can be accessed by referring the block number, like a disk and a USB driver. And the character-oriented is input and output data in the form of byte strings. No fast structure like a terminal printer, an end printer, yeah. So how I/O operations are organized in an operating system. Here you can see three methods. The first one is programmed I/O. The process issues an I/O command on behalf of process to I/O module that process the busy waits for the operation to the complete for the proceeding, as said by the William. And about the interrupt driver I/O, the processor issues an I/O command on behalf of the process. There are then two possibilities. And about direct memory access, DMA is very important because DMA module controls the exchange of data between main memory and I/O module. The processor sends the request for the transfer of the block of data to the DMA module and is interrupted only after the enter block has been transferred. So here you can see 5 disk schedulings. I give you example from the textbook. The start at track is 100 and the request track is this you can see, yeah. And about FCFS, it means processes item from the queue in a sequential order, first come, first out. And here you can see SSTF and scan, cscan, and log. And the result, you can see the average seek length. When we use this disk scheduling, you can see the different average seek length. And I'm sorry, here is yeah, you can see SSTF where it will create a shortest average seek length. What about RAID technology? It was separated by 6 levels. So here you can see the level 0. It's unique within these 6 levels. The user and system data and distributed across all the disks in array, and the disk is divided into multiple drops. It's very important concept, like physical block and sectors. And the advantage is it has high data transfer capacity and high I/O request rate. So here you can see RAID level 1, 2, 3, 4, 5, and 6. And about level one, its advantage about level one is improves the performance of data transfer, but it will create high cost. But so in level two, it uses parallel access technology and use data stripping with very small strips. And so the advantages means is effective in environments with the frequent disk error. But the disadvantage is given the higher reliability of individual disk and the disk driver, so it may be were overskilled and not implemented. So what about level three? Level three only one redundant disk is required using parallel access. And you can see, yes, the advantage and the disadvantage. And level four, you can see here in this chart, you can see advantage and disadvantage. Okay, this chart is from the textbook. The second part is about secondary storage. Here you can see allocation strategy. There are three types of allocation strategies. The first one is contiguous. It's a single contiguous set block is allocated to a file at a time of file creation. And you can see the advantage is can read multiple blocks at once. Easy to retrieve a single block, but it will create external fragmentation. But you can see the link strategy is based on the single block allocation each block. So it's not create external fragmentation, but the principle of locality is not applicable. What about the index allocation? This method, you can see the file allocation table contains a separate one level index for each line. The index has one entry for each portion allocated to the file. Typically, the file indexes are not physically stored as part of file allocation table. So about this strategy, it can reduce the advantages like contiguous and linked. So here you can see the advantage of the index allocation is it can eliminate external fragmentation and also can improve locality. So here, how file system keep track of free storage space, technologies for managing free space. Three methods. First one, bitmaps. Second one, linked list, and the last one is grouping. About volumes, volumes is a collection of addressable sector in secondary memory that operating system or application can use for data storage. So here you can see two methods to control the volumes. The first one is multing. Multing is a process of making a volume accessible to the operating system by attaching a directory tree. And about unmulting is the process of the detaching a volume from the directory tree. Ensure all pending operations are completed. And then the next question is how file system handle errors and data loss. Here you can see three methods. First one is redundancy. As I introduced before, you can see the red one and 5, 6. It can you can see the duplicated data on the two disks or distributed parties across a disk to recover from failures. And about tolerance, it means design to continue operating even when hardware fail. About backup, it's very is very normal in our daily life. It includes full backup, incremental backup, snapshots, and cloud backup. Last part is file system recovery data. Here you can see journaling is mentioned by the textbook. It means in the Windows system, it's keep a log of all changes made to file on the volume. And here you can see read and the backup. Okay, this is my part.
I'm Xingye 2, and now let me introduce my part. First is file systems in different operating systems. First one is structure and the function of the Unix file system. The first is inode. Inode is the core data structure of the Unix file system. Each file has a Unix inode storing metadata like file size, creation time, modification time, and permissions, but it does not store the file name. And then it's blocks. Blocks represent the actual storage units, and while nodes act as a map to locate them. And then is directories. Directories work like a contact list, linking human readable names to system recognized identifiers. And then is file allocation in Unix. Unix employs indexed allocation, and small files fit directory in node pointers, while large files use multi-level index pointers for efficient data access. And then is links in Unix. First is hard link. Hard links are aliases pointing to the same inode. Multiple names share the same data, and deleting one link does not affect the others. And then is symbol link. Symbol links store a reference to the target file's path. If the target is deleted, the link becomes invalid. And then is file access management in Unix. First is permission. File permissions are categorized for owner, group members, and others, including read, write, and execute, modifiable, and via command. And then is user identification. Unix manages access via user ID and group ID. And then is ACL access control list. Unix supports ACLs for granular permission control over files and directories. And then is Linux virtual file system. First is its concept and function. VFS is an abstraction layer that provides a unified interface for file operations, such as opening, reading, and writing files. And VFS ensures a consistent experience, whether the file system is on a local disk network or virtual system. And then is core objects of VFS. And first is super block object. It represents a mounted file system storing its type, status, and other details. An inode object represents a file or directory storing metadata like size and permissions. Then is free object. It manages the mapping between file paths and the inodes for quick lookup. And then is file object. It represents an open file instance, including its access mode and position. And then how VFS works. First, mounting file systems. VFS mounts different file systems into a unified directory structure. And then operation abstraction defines common operations such as read, write, and implemented by specific file systems. And then caching. It speeds up file access by capturing paths and metadata. And then there is an example between local disk and network file systems. And then is the structure and the function of the Windows file system. Windows support FAT32, EXFAT, and NTFS. And with NTFS being the most commonly used due to its strong security and performance. And the key features of NTFS. NTFS volume structure includes the master file table and the log area to store metadata and operation logs. And file structure, the small files are stored in MFT, and while large files are stored externally. And the recovery features, it uses logs and checkpoints to maintain data consistency and recover from crashes. And permission, it provides fine-grained control using access control lists. And then it's comparison between NTFS and other file systems. And first is with FAT32, and NTFS supports large files and advanced features, while FAT32 is for simpler devices. And NTFS with EXFAT. EXFAT is designed for flash drives but lacks NTFS security and features. And between EXT4, NTFS focuses on recovery and permissions, while the other one prioritizes performance and scalability. And the advantages and the limitations. Its advantages is it supports large files comprehension, encryption, and journaling. And limitations is less compatible in embedded and cross-platform environments. And then is file management systems. And first is the overview of it. A file management system is a component of the operating system that organizes, stores, retrieves, and protects files. And then is functions of file management system. It contains file definition, file naming, file structure, file access management, and file reliability. And then it's challenges in file management. There are some challenges that we meet. First is data consistency. It ensuring file data remains consistent during concurrent access or crashes. And then it's permission management. It's defining and enforcing complex permissions. And then it's storage efficiency. It is used to balancing disk space utilization and performance, avoiding fragmentation. And then is scalability. And then is cross-platform compatibility. And then is key functions of file management systems. The first is file definition and classification. And then is file naming and path management. And then it's file storage organization, and file access control and data protection and recovery. I think the most important is in file definition and classification, it defines file attributes via metadata such as size, type, and they provide classification mechanisms. Next is method for organizing files. The first method is sequential access. Data is stored and accessed sequentially, ideal for log or streaming files, and it is easy and high efficiency, but it can't access very quickly. And then is direct access. Data stored in fixed blocks enables random access by block number. Um, it is support random access and quick and reading of specific blocks, but it is very complex to manage. And then is indexed sequential access. It combines sequential and random access row and index file. It is flexible and high efficiency, but it needs extra space. Is organizing files in a hierarchical system using directories. And directories in the file system manage and organize the files. Hierarchical system use a tree-like structure to represent files and directories, making file management intuitive and efficient. And there is different implementations of directory structures. First is linear list. It stores file names and as a simple list with metadata recorded sequentially. It is simple to implement, efficient for inserting files in small directories, but it is low efficient and not scalable for large directories. And there is hash table. It uses a hash value of file names as an index to speed up searches. It is high search efficiency, suitable for directories with many files, but it can degrade performance. Dynamic expansion requires rehashing. And there's tree structure. It organizes directories in a tree structure where each node represents a directory or file. But it supports hierarchical relationships, efficient for locating files and using paths, but it is higher complexity and it requires more memory and optimized algorithm for large systems. And that's all. Thank you.